along the way. So hello, everyone, and welcome to today's session of our Glaze webinar series. And the presentation today is entitled Off-Season Strawberry Production Under Lighting in Controller Environment. The Glaze Consortium webinar series is a selection of live recorded online presentations that cover a broad range of topics at varying technical levels and scale. These webinars feature the latest technology innovations and best practices in the CEA field, providing the audience the opportunity to discover new solutions and to connect with field experts. I would like to introduce everyone here to our presentation today, Dr. Chieri Kubota. Hello, Chieri. Dr. Kubota received her PhD at Chiba University in Japan, and she's now a professor of controlled environment agriculture at the Department of Horticulture and Crop Science at The Ohio State University. Dr. Kubota's mission is to serve in the development of science and technology in the area of controlled environment agriculture. Her projects are in an interdisciplinary area that encompasses plant physiology and horticultural engineering to enhance understanding and efficiency of CEA plant production systems, such as greenhouses, warehouses, which we also call vertical farms, and growth chambers. A recorded version of this webinar will be available at our website afterwards, so glaze.org. Everything is available there. If you have any questions about the presentation, or if you'd like to get in contact with Chieri afterwards, please submit your inquiries using the chat box. So we have the chat box and the Q&A. I would say use the Q&A, it's easier. At the end of the presentation, we're gonna go back and we're gonna try to answer all of your questions. So with that said, I would like to give the word to Dr. Kubota. Chieri, thanks for being our presenter today, and we look forward to your presentation.
Well, thank you very much, Eriko. That's a very nice introduction. I really appreciate. So, hi, everyone. I see 99 people participating. That's great. I'm Chieri Kubota. I'm a professor here at The Ohio State University. What I do here in Ohio State University is pretty much technology development to contribute to the industry in CEA. And my approach is always problem solving. Not just current problem, but potential problem in the future. I take scientific approach, so using scientific information to find out the strategy to solve the problem. So I worked many crops. Tomato was the first one after I moved to University of Arizona 2002 from Chiba University, Japan. And then I worked on vegetable grafting, transplant production in indoor artificial environment conditions. And then strawberry is relatively new addition in my program. So today's topic, I'm going to talk a little bit of the big picture, North American strawberry industry overview, and then talking about the current status of CEA strawberry production and then opportunities in there. And then I like to talk about lighting because it's a Glaze webinar. So I like to talk about lighting and what specifically, technologies are needed for growing strawberry under a controlled environment. So I'm going to talk about targeted lighting. I'm going to talk about efficacy of supplemental lighting and a little bit of photoperiodic lighting. And then also the lighting effect on the flavor, not spectral per se, but electric lighting versus sunlight type of information. So anyway, if you are ready, let's move on. So North American strawberry industry, it's very unique. California did a great job over the past many years establishing industrial, efficient, I would say large scale outdoor production. And then California can produce year-round. However, if you can see this monthly shipment data, the summer is, of course, the biggest production in California. But because, even though shifting the production site to southern area, their production has to be largely reduced. And then during that month, Florida is traditional, winter strawberry production site. Again, outdoor, and then nowadays Mexico is a strong producer. in North America. So if you look at the map right here, the size of the strawberry is showing basically the acreage of strawberry. And then the California is the largest in North America, 72%. If you just look at the US, California is of course more than 90%. And then we have now Mexico and Florida. And because of the big fluctuation of the production, the price point goes up and down. So that when the production is high, the price point is low, and production is low, price point is high. So that means off-season production, particularly sometime starting from October all the way going to February, March, is a big, big opportunity for controlled environment agriculture. So if you look closely where exactly strawberries are coming from, in California, you find that pretty much 3 areas. Watsonville is a huge summertime production area. And then Oxnard is also very important because they can do winter production. So, and then Santa Maria area, that's in between. So 3 locations pretty much contributing 90% of US consumed strawberries. And then Florida, it's pretty much one location, which is quite interesting. So my former graduate student used to work in strawberry industry, and he used to say that strawberry is very much limited by geographically. So where to grow is the big limitation because not many places are perfect for strawberry crop production. So this is a traditional or conventional strawberry production scene in California, soil bed covered with mulch and then open field. So workers need to, bend down and then pick the fruit in this situation. So they basically the large scale production. And then, as I said, most of the strawberries are produced in here and then shipped long distance to reach all over United States and beyond, Canada, and sometimes overseas also. So they have to come up with good post-harvest technologies. They use something like a modified atmosphere packaging shipping technology. This worker is here injecting gas that doesn't have high oxygen concentration, so reducing the oxygen in the package to about 1% or 2% level. So by injecting either CO2 or nitrogen, so that reducing strawberries respiration rate. Reducing respiration during the shipping is very, very critical. So that's why they do. In addition to that, the temperature is of course very critical. So the optimum shipping or storage temperature is 32 degrees Fahrenheit or 0 degrees Celsius. And then this forced air cooling system allow you to get the temperature of food down to the 32 degree Fahrenheit quickly. So those 2 technologies are very, very important. And then also what we call cold chain technology. So the cold chain meaning from this point all the way to the retail store, strawberries are maintained at very low temperature. And then also another contributor of such a big industry in US producing strawberry is of course, the breeding. Cultivars that can flower during long day, the summertime, is a big contribution so that California can produce strawberry during summertime. And then also, good strawberry, not necessarily flavor, unfortunately, but the shelf life wise is very important. 2 weeks of shelf life is important. So I grew up in Tokyo, Japan, not knowing, where the strawberry is coming from. And our strawberries are typically grown in greenhouse in winter time, and then typically consumed within a few days. So it's very short shelf life because country is so small, and then also we are more into the flavor and taste rather than shelf life and something else. So anyway, so that's the situation. And then this book published by UC, so the University of California Press, it's really good to know what's going on in the current American strawberry industry. What is the limiting factor? Why it is so challenging right now? What is the risk? So those things you can learn. Pretty much strawberry industry was established upon this super duper fumigant to treat the soil, to eliminate the pathogens and then also weeds. But that chemical is no longer available. It's a methyl bromide, so it's not good for environment. Therefore, many countries already stopped doing it, and California strawberry industry also stopped using that chemical. But finding an alternative chemical fumigants is really challenging. So new diseases coming up. So that's one of the big issue right now going in strawberry field. And then of course the global, climate change, drought, and other conditions make the outdoor production often challenging. And then increasing labor cost is another thing. Increased minimum wage, and also more regulation over migrant workers. So those things are very important things they are working on right now. Another thing is Mexico is becoming a very large competitor in the US, particularly for off-season production. Many years ago, Mexico was not even top 10 of the strawberry production, but now it's number 3 worldwide. Number 1 is China, 2 US, and then now Mexico number 3. So that's a big jump. And then in California, the Baja California area, San Quintin, that's a huge strawberry production area because the climate is very similar to California, and they can create that climate during winter time. So that's perfect to do winter production. And then another thing as a background is maybe consumers are more concerned about, sustainability, and then they would rather see local fresh produce than something shipped long distance. So that's another background. And then California growers also testing technologies right now. So this is called tabletop system. This is the substrate-based strawberry production using drip irrigation. Because it's California, you can use you can use what we call low-tech controlled environment. So in another word, it's a high tonal type of production. So the protecting from wind and rain, but they use the gutter system to collect the nutrient solution, and then drip irrigation so that they can minimize the water and nutrient use. And then it's a raised gutter, so workers look at that, they don't need to bend over. So it's really efficient for workers to work on the plants and harvest the fruits. Controlled environment greenhouse production has been around many years. As I said, only thing I know is that strawberry is a typical crop in greenhouse back in Japan. And then also now European countries are doing a lot, controlled environment greenhouse strawberry production. And it is a fast growing industry sector because we don't have any many years ago in US doing a greenhouse strawberry production in a sizable scale. But now if you look at US, California, Michigan, New York State, Ohio, Tennessee, they have quite a bit of acreage, not as large as tomato growers, but probably tens of acres they have. And then Canada is a leading country in terms of controlled environment strawberry production, and then Mexico too. So the picture here is the Ontario, Canada, and then the left-hand side, lower side is the Mexico controlled environment production. And driven by urban food system. So they are looking at off-season with higher price point. And then also behind the scenes, retail stores are taking a major role, investing in growers or encouraging them to do strawberry production locally. And And then a great thing of that, not just off season, if you are in the right climate, you can do year-round production. And California is doing that. Ohio is not yet year-round production. It's more like a fall to spring production, avoiding summer because of the fruit quality. And then that's exactly what I have been working on too. And then something we don't see yet is a potential winter urban ag tourism opportunity. Think about, outside it's very cold and maybe snowing. Think about strawberry greenhouse in the urban area, suburban. The family and friends get together and pick strawberry and eat strawberry, and then enjoy the time. That's very popular business. And many greenhouses are doing in Asian countries and Australia, New Zealand probably, but I know Australia there are a couple doing this type of business. And then I like to see that in US too, because it just makes sense. And then also opportunities include discovering or rediscovering old varieties which were probably forgotten because of maybe the shelf life issue, maybe because it doesn't have the good disease resistance or some of the soil-borne disease, but because it's soilless production, because it's local, I think those cultivars can have opportunity to come back to the market. All right, so I started leading the strawberry program at University of Arizona 2009. We had an undergraduate student several years prior to that doing an NFT-based strawberry, but it didn't go successful. And then I seriously started working on with Mark Rogo in the year 2009, thinking that strawberry is going to be very important crop for greenhouse industries, because still greenhouse industries, major crop coming out US greenhouse is tomato. And then it's, diversification of the crop selection is some of the missions I had. So I started working on and still working on strawberry. So the up to 2017 was based on Arizona, Tucson, Arizona, University of Arizona Controlled Environment Agriculture Center. And then 2017, I moved my lab to, Mark and I moved to Ohio State, and then continue working on that. So this is my greenhouse right now in Ohio State, Columbus campus. So when you do strawberry production, there are so many things you need to figure out. And then we did so many things we figured out. And then not all of them we figured out. But this is a list of things like a cultivar planting material, crop scheduling, and nutrient management, environmental control, IPM, integrated pest management, physiology side. Strawberries, what a complex, the strawberry physiology is. There is a flowering response, vegetative, reproductive, balancing, and then they are sensitive so many environmental conditions. Root zone, you have to maintain the optimum environment. So it's not a easy crop to grow. So it took us about 3 to 4 years, started feeding that we are finally ready to start disseminating this technique. So it was around 2010 or so, I think. So anyway, so those are the ones you need to know to do strawberry. And then I don't have enough time to cover everything today, because I wanted to focus a little bit more on lighting side. But I want to introduce our new website, Indoor Berry website, or Controlled Environment Berry Production Information site at Ohio State University. I had one in Arizona, and then finally moved that website to this new platform, and then added new information to update. So it is a very useful information. And then I encourage you to connect with us or look at the website and then ask questions. Not everything is completed yet. For example, I don't think I completed photosynthetic lighting, supplemental lighting section, although I'm talking much here. So things like that is coming up soon. So yeah, so University of Arizona is located right here, Tucson, and then Ohio. And then you can see that huge change, you know, by just looking at this map from sunny, nice climate in winter, very hot and dry in summer situation to, you know, good spring and fall, and winter is very dark and cold, Ohio. It's a big change, but it was a great opportunity for me as a controlled environment scientist because I could test the same method, same cultivar, you know, in a two distinctly different climates. So I learned quite a bit, and Mark Rogo, my collaborator in this project, learned quite a bit too. All right, so every state has strawberry production outdoor. It's just a small, so because California is humongous, so you can't compete. But they are doing, you know, local produce production, and then providing fruit to the local market. So this is our Ohio-based or Midwest-based strawberry production, typical production schedule, starting in August of the previous year to produce mainly June of the following year. So the in between, you have, or we have vegetative growth period. During the time, the flower initiation happening, but outdoor condition goes, you know, short day and super cold. So plants basically going into dormancy, and plants do not come back until the temperature comes back to the growing range. And then that's usually here at March, and then start growing and then developing flower truss, and then flowering, and then fruiting. And early crop might be in May, maybe under the little bit of protected environment, but majority is June. And then many growers like to use plugs because plugs are available in US, but those plugs and then also alternative or more traditional planting material, bare root plants, those are not really designed to produce big production in October or November. Usually that immediate season is used in the field to just establish the vegetative growth so that it can support the big production in the following year. So that's what typically see in a Midwest situation. So what we are trying to do is my collaborators, Brad Burgiford and Mark Krogo in Ohio right now, is trying to promote two other alternatives, you know, not just outdoor production, but extended high tonal tabletop production, as well as greenhouse-based off-season production. Three together, I think we can do a year-round supply, not necessarily year-round production from one site, but many, many growers basically providing at different timing of the year. But for consumer standpoint, when they go to the grocery stores, they can always see something coming up somewhere in Ohio, and then provide the fresh strawberries, not traveling so many miles. So whenever you are going into strawberry first time, and then we did this when we moved to Ohio too, you really need to pay attention some of the climate environmental factors to decide what is the optimum production cycle in your site or potential site, and then also what kind of materials and cultivars you should use. The first thing, super important, is the night temperature. So the greenhouse night temperature is pretty much equal to outdoor temperature. You know, if you are not heating, heating to increase the night temperature is super easy, right? Technically, it's not challenging. Lowering temperature is really challenging at night. You know, evaporative cooling doesn't work at night, so the only way you can do is the mechanical cooling, so the AC unit. And then you don't want to do that because it's very expensive. But anyway, so the strawberry, because flavor and size of the fruit is pretty much affected by night temperature. This is the recommended night temperature, 50 to 55 Fahrenheit or 10 to 12 Celsius degrees. If it is lower than that, you can again increase. It is higher than that, it's a problem. Well, you might be able to accept if you can accept small fruits, if you can accept very tart fruits, not flavorful. So that's the one thing we always pay attention first. Day length is very important because strawberry is pretty much photoperiodic. So that means day lengths affect flower initiation. And then also strawberry has dormancy or semi-dormancy, and then day length is a factor for semi-dormant situation, going into the dormancy type of morphology, even though temperature is growing temperature. So understanding that is very important. For short day cultivars, understanding maximum day lengths you can reach is very important, particularly for off-season production, because if you can extend the day lengths, stretch out, that means you can reduce the light intensity to provide the same amount of light. If you have only limited day lengths available because of the short day response, you have to put more light. So understanding that critical photo period, where is the threshold, is very important. And then we found that 13 hours is pretty much maximum out of our experiment. And then the strawberry has another group of cultivars calling everbearing or day neutral. And then they are pretty much long day plants. And then understanding that response is very important, again, for designing the lighting environment. And then also some, unique interruption or the interrupting lighting, cyclic lighting, or let me go over. So the cyclic intermitting lighting or night interruption lighting, those are the typical lighting for preventing plants from going into dormancy type of morphology. So that's been done many years in other countries. Understanding potential temperature conditions in different seasons is very important because warm temperature actually prevent flower development. So even day lengths and everything is perfect. If the temperature is as warm as I think 80, 85, I think 85, like 26 degrees C, it starts affecting negatively flower development. So you wanna understand the temperature. And then also we know that by literature, strawberry optimum temperature is around 18 degrees C. So that's an average of the 24 hours. And then, of course, DLI, daily light integral, is important to understand the productivity, potential productivity. And then by observation over the past, 10 years in greenhouse, minimum day length, minimum DLI, daily light integral, we recommend to be productive is 12 moles per square meter per day, 12 moles. And then good productivity usually happening between 15 to 25. And then within that range, more light is better situation. So if you can achieve close to 25, of course, it's good. But 15 to 25, it's a reasonably good productivity. So this is a Midwest-based cycle or the production cycle we recommend in this area. So the planting we want to do plants. Tray plant is a technology of producing, or the tray plant is a type of transplants available in European countries and then now finally in US. It's a big plant, not the single, crown, small plants traditionally used in strawberry industry, but multi-crown, very big root system, like a 300 milliliter root ball, designed to produce big production right after. And that's what we want to start with. If it is June bearing type or short day type, you of course need to do conditioning. Plants need to have flower initials. Otherwise, you have to wait all the way to the December or maybe January to start harvesting. If plants are ready having flower initials, either conditioned June bearing cultivars or the other ones, ever bearing day neutral, they can start producing October. So that's what we want to see, and that's what we try usually in this climate. And then all the way, continue continuously every week, or every other day, you can harvest fruits, and then all the way to the end of May. We stop at the end of May. Why? Because temperature is no longer in this ideal range. As soon as temperature goes to 65, 70, your fruits are no longer flavorful, small, and then not so good. So during that fruit production period, we try to achieve the conditions, and then also light. So of course in Ohio, we need heating and lighting in these months. Okay, so that's what we do. So whenever you want to do lighting design or think about the off-season production, you want to understand the requirements coming from plants. And this is something really, it was really hard to find when we started 10 years ago. Nobody report critical photo period of June bearing cultivars, although we know those are short day plants. Because open field production, there's no motivation to find out, because there's no, you don't control day lengths in the open field, right? So that in the greenhouse, we can control day lengths. Therefore, we want to know what is the critical photo period, and what we want to know what is the exact, photo periodic response of those ever bearing and day neutral. Another good sort of observation I had is strawberry industry called day neutral varieties, but they are not day neutral in a strict definition in controlled environment. They are long day plants, facultative long day plants. So anyway, so the first thing we worked on is finding out the light requirement, photoperiodic light requirement of US cultivars. All right, so this is what my former graduate student did. Cara Garcia, she did a great job in this study. And then also another one I don't have time to share, but she did selected major cultivars of short day June bearing, and then also ever bearing, and then designed the experiment so that they have almost the equal amount of DLI per day, but extended with very small amount of light under the totally controlled temperature during the nighttime and extension light period. So that during the day, 7 hours, it's under the sunlight in the greenhouse in Arizona, and then extended light with small amount of, PPFD. So, and then that's the for short day experiment, and long day, similar way, but we had tested much wider, photo period range. So what she found is quite, encouraging. 4 cultivars shown here, all of them showing no flower development. By the way, the y-axis is the flower primordial developmental stage. Higher the number, it's very much advanced flowers. So you can see that up to 13 hours, flower initials were already developed and an advanced stage, but 14 hours, there is none. So that means critical photo period of all these cultivars exist somewhere between 13 hours and 14 hours. In terms of long day response, so those are the cultivars typically classified as ever bearing or day neutral. They are positively responding most of the cases, increasing photo period. So the longer the photo period, the flower initial advanced the development stage. There was only one cultivar showing almost a neutral response, so that regardless of the photo period, Potora didn't show much of difference in terms of flower stage. So that was quite interesting. So here is the, how it looks, Arizona greenhouse, and then Ohio greenhouse side by side. And then you see that the biggest difference is the light. We have to rely on supplemental lighting quite a bit in Ohio because we don't have enough DLI coming from the sun during winter months. So to talk about lighting design of strawberry, I like to start with this, how strawberries are set up in the greenhouse. We use system, so as most of the greenhouse growers. And then this is the industry standard gutter width, or the distance between center and center of the gutters, 3.3 feet or 1 meter. And then within the gutter, usually have a double row system. So plants are growing in the double rows. And then meter density is a sort of information we use instead of standard, area-based density. But 8 to 10 plants per meter is the industry standard. Maybe the here some of the growers are doing, but I would say 8 to 10 standard. And then because the distance is 1 meter, area density is also 8 to 10 plants per square meter. So that's the situation in our industry. And then in that kind of growing system with short stature plants, when you do supplemental lighting using our existing technology, you're basically wasting a lot of energy, because traditional lighting system is designed to spread the photons very evenly over the plants to create the uniform horizontal light distribution. But strawberries are growing in the rows, and then they are short stature. So there is not much surface to receive the photons. So look at this picture. Basically 30–40% of light is wasted by illuminating nicely the floor area where you walk up and down. So this doesn't work. So the first thing I worked as soon as I came to Ohio is finding out alternative lighting system that makes sense in this kind of crop production system. So so fortunately, the local LED company, spec grade LED, collaborated with me to put the my concept, targeted lighting over the plants. So targeted lighting, because of the LED, you can target, right? You don't have to spread the beam angle. So you can target just about the canopy area. It's about 60 centimeter or 2 feet, and then not wasting much on the floor. And in that way, I could increase the light intensity. I could increase the efficiency of the usage of the light. Another alternative, which is probably more common, being considered in commercial setting, is the movable gutter system to create continuous canopy, so the high density production. But once you do that, then you can't really reach your crop. Strawberry, you need de-leafing, you need fruit, harvesting. So almost every day you need to attend your plants. So for this one, a design to have gutter go up and down. So whenever workers need to have access in a walkway, that particular gutter goes up. So by doing so, you can continuously use the traditional lighting. So either of the two, you can save the energy in supplemental lighting for strawberry. So as soon as I started doing that, I sort of realized that some of the analysis I did for supplemental lighting for strawberry was very unfair to strawberry producers. So this is a paper I published, or I wrote and then published 2016. And then it was basically asking the question, the question is, does supplemental lighting make sense for this crop? Because supplemental lighting require electricity, so the electric cost versus return, which is increased yield, and then you have to evaluate the economic value of the increased yield as a gross profit, and then you have to compare those two to see if putting more light actually give more economical return. So I did analysis for 3 crops. So this is a little bit busy chart, and then I always have a difficulty to explain really well. But the black curves basically showing the electric cost, and the dotted line is with offset of reducing heating energy, because any lights going in, you can reduce the heating cost because lights generate heat. So whenever the productivity or the gross profit exceeds those lines, so the gross profit is the red lines, that means the usage of light is profitable. And then the reason it is diagonal like this, the cost curve, is because the cost is affected by the efficiency of the light, efficiency to convert electric power to the photons. So that's why going down with increasing efficiency. So the HID lamp, high pressure sodium, it's probably 1.7, 1.8 number-wise in terms of efficiency, and beyond 2 is really LED range. And then now I think much efficient LEDs available because this is a 2016 comparison. But anyway, so the lettuce crop, the gross profit is way above of the cost of the lighting. Tomato is an intermediate, and strawberry is very low. And then I concluded that time it doesn't make sense to do supplemental lighting over strawberry crop. So as I said, because this is the way I did, I assume the uniform lighting over the greenhouse floor space, so that basically wasting a lot of light. So I decided to redo this analysis. Oh, by the way, this chart is basically shown in standardized value per mole of light. That is an easier way to compare the same way for the cost and then also productivity. So this is the productivity numbers I used. So grams of fruits you can gain by adding 1 more mole of light in a space. So you can consider as a per square meter base, or you can consider whatever. Tomato is quite productive, up to 14 is reported. Versus strawberry is very low, very slow growing crop. That's why the value is very low. How do I find this? This is from the linear regression between cumulative light and then cumulative yield. And then you can get that number. And then the wholesale value is a sort of anecdotally I discovered or I heard is plugged in, and then grams and then value that gives the potential gross profit, considering some cost increase because more yield and more cost also for picking and all that materials and everything. So I worked with my economic collaborator to find out what is the good percentage of that gross profit point. But anyway, so again, I said it was in this kind of situation, so I decided to redo to the more redo under the condition more how do I say fair to the strawberry crop, either targeted lighting situation or continuous canopy situation with movable gutter system. So basically I could increase the productivity that way, because earlier it was the floor area based average. So that was why I'm saying it's not fair situation for strawberry. So as soon as I looked at the canopy area-based number, the productivity goes up 60, 70%. And then that accordingly, increase the efficacy of lighting dollar value you can expect as a gross profit out of 1 mole of addition of light. And then now I can see the difference. This is the one earlier. It's no way to make the profit because it's lower than the cost. But now both lines, which is the highest one and which is the midpoint one, is exceeding the cost. Again, this is the cost of electricity for supplemental lighting to get 1 more additional. And this is with considering offset by heating. So you can see that particularly when you are using good lighting technology, you get a lot of profit out of strawberry in the supplemental lighting. So I feel good about continuously working on strawberry in Ohio conditions, because we can't grow strawberry without supplemental lighting. So another kind of supplemental lighting, just quickly as an information purpose, photoperiodic lighting. That's a very unique type of lighting. Not just long day crop to create sort of artificial long day by night interruption lighting or intermittent cyclic lighting, but also used for the other way, but also used for a short day crop, which is kind of counterintuitive because short day, why you have to create long day? But plants typically go into dormancy type of, dwarf or the rosette type of morphology and reduce the productivity under short day. And then European growers, Asian growers, they use short day cultivars, but they apply photoperiodic lighting to improve the morphology. So very short period of time, you know, several days, 2 weeks, just to make sure that morphology comes back, and then stop doing that because they don't wanna affect the flowering. But it's a quite unique technology. And then the great news is that the light intensity requirement is very, very low. Photosynthetic supplemental lighting to promote or add DLI, usually you go 100 micromoles, sometimes more than that. But photoperiodic lighting, you can do that with only 2 to 3 micromoles, very low light. So this is a sort of our conditions, growing methods. Arizona and Ohio, again, the biggest difference was we didn't use any supplemental lighting. It was not necessary. So that's why 100% solar radiation. We did a lot of shading instead, 50% shading minimum during the months of March, April, and then May we stopped, early May we stopped growing because temperature was too high. In Ohio, we use heavily supplemental lighting, and majority of our DLI during midwinter time is actually coming from supplemental lighting because sunlight doesn't do a good job in Ohio. So one of the quite unique finding my graduate student found, Tom McKean found, was that the strawberry flavor in Ohio is really good. And then we compared the value with what we have been, obtaining in Arizona. And then we found that the Brix to TA ratio was highly significantly different. So the Ohio berries, this is the same cultivar, the same production method, same PI, right? And then same decision type of making. But we found that the flavor is outstanding, Ohio. This small difference, actually, you can tell it's really different. So we are curious what is really causing. And then I kind of knew because we looked at different season in Arizona, but I wanted to scientifically prove that. So if you compare Arizona climate during the fruit production time, and then also Ohio climate, and then look at closely the difference, the biggest difference is the nighttime temperature. Ohio, because outdoor is so cold, it maintained always around the set point. So that's a big difference in Ohio and Arizona. And then what I suggested to my graduate student is look at Arizona data. Here is a multi-year data, and then finding out the correlations between environmental factors and then fruit flavor. So that's what he did. And then try to explain why Ohio strawberries are good in terms of flavor. So this is Arizona data-based analysis. So we only look at Brix and TA, titratable acidity, nothing else, nothing like a flavor, boratol and things like that. But those are the two major components to actually represent the taste. And then what we found was titratable acidity was highly affected by environmental conditions, and specifically all temperature-related variables, 24-hour temperature, night temperature, day temperature, highly, highly significant. And basically lower the temperature, lower the acidity. So that's what we found. Brix was not affected by environmental conditions. Brix was more affected by cultivar itself. So selection of cultivar is another important thing for strawberry production. And then, so these are the temperature comparison between Arizona and Ohio, the same chart, but highlighted temperatures. And then we had nighttime temperature, very significant. So we concluded that likely that nighttime temperature was the reason we had lower acidity and the significant difference in Brix and acidity ratio. But one thing we couldn't analyze in this set of study or experiment But I know that's probably the reason is the daytime fruit temperature effect. So we just analyzed the daytime temperature, air temperature, and then there's no significant difference. But if we had sensor, the temperature sensor in the fruit, we probably sense the temperature difference in the fruit under the sunlight and then under the electric lighting. So the sunlight is Arizona situation. Again, we didn't do any supplemental lighting. And then as you know, sunlight contains PAR and then also heat. 40 to 50% of the energy coming from the sunlight is pretty much heat. It's only 40-50% is the PAR, so the photosynthetic active radiation, versus electric lighting pretty much 100% PAR range. So that means if you set the light intensity about the same in terms of PAR, sunlight comes additional energy in the thermal radiation. So obviously, strawberry under the light would be higher in temperature under the sunlight than electric lighting if the PPFD or light level is the same. So that's probably contributing. Lower the temperature again, better the flavor. So that's the sort of finding. All right, so more information available again. If you are interested, this is a website again, u.osu.edu/indoorberry. If you want to have more training, hands-on training, we continuously provide hands-on training. I think we have been doing many years now and continue doing so. Our strawberry training, because it's a sort of new crop and then not many people want to share their interest and then plan, we do one-on-one or group based so that you can bring your colleagues and then we can set up the day for training. So usually having a multiple lectures in the morning to understand strawberry physiology, production systems, and integrated pest management. And then afternoon, we have a couple of hours going out in the greenhouse and then work on the crops and look at the morphology and look at the fertilization control, all that hands-on part. And then coming back in the conference room and then talk about business model, if we can help anything by discussing specific what they want to do. And we can even estimate the roughly potential yield coming out from that site. Based on the light available in that site. So Mark Krogo and I provide that training, and contact person is Mark Krogo, krogo.4@osu.edu. So I want to show off this. So Ohio State is investing a lot to strengthen the capacity to work, research and education and outreach in a controlled environment. And then we are building Venlo modern Dutch style greenhouse complex in the campus, Columbus campus. And then one of the compartments is going to be designed for strawberry research. So we will be able to do more relevant, we will be able to do research and education extension in a more relevant type of technology setting to the existing and then future industries in the US. So with that, I'd like to thank very much for all the industry partners, contributors, and organizations who supported our 10-year strawberry program. And then we wish to continue working together. And thank you so much. And those are some of the other websites other than strawberry. And then my email address if you have any questions. Thank you very much.
Thanks, Chieri. That was a great presentation. We have now 5 minutes to 3 p.m. and we have a few questions. So let's see how many we can get answered. And if we can get a few minutes more, let's see if we can roll on that. That'll be great. I just want to open the questions here just before bringing for the public. You mentioned about having winter strawberry production as a touristic activity. First thing that came to mind is when we're going to see strawberry flavor eggnog. I'm a big fan of that.
Strawberry flavor eggnog. Wow.
I look forward for that. I think that's a good outcome of that.
Yeah. But the good strawberry, you don't need anything. Just eat as it is, and then just so good.
Can argue with that. So I will start with a question, Chieri, and then we go for all of those. You mentioned about the movable. My question is more related to lighting, right? The movable system and the target lighting design. So those are two options to increase the efficiency of supplemental lighting in strawberry production. If you
Right.
need to pick one of those, is there a better option, or it really depends on the setup and how the greenhouse is designed?
I think right now many growers are basically transitional growers, like used to be tomato growers and now wanted to do strawberry, and having already light set up. In that situation, I think considering movable gutter as additional investment is a good way. If you're designing new greenhouse, I think it's depending on the cost. Uh, Movable gutter is more expensive than traditional gutter system. So you might just do LED-based targeted lighting. I think we need to do a bit more analysis, the cost and profit.
Sure. Yeah, and that's a great one of the great advantages of LEDs. You can
Right,
always
right.
customize with lenses and shapes and form factors. So that's
Yeah, yeah.
great.
Right now, I need to mention that right now, I don't think there is a commercial targeted lighting system available. The one I used was a prototype, um, supported by spec grade LEDs. Um, so it's custom built as a prototype, but there is no commercially available targeted lighting, because it's based on the height above the canopy, and then also usually 60 centimeter, but so that you have to have that height information to design that light. So it may be actually end up with more expensive if it is custom.
Yeah, yeah. Well, but looking for the height and the lenses and how you
Right,
place the lights, yeah, as lighting design, it's a great topic to be explored. I might promote one talk just on that. Might be a good discussion for this
right.
group here one day, talking about the potentials and pros and cons about that. So some questions from the audience, Chieri. One of them is, what would be the optimum photo period? Would be 18 by 6, 20 by 4, for example, or something else for sole source lighting and greenhouse lighting for strawberry?
Yeah, so first of all, 18 or 16, you have to use ever bearing or what we call day neutral variety, so that your plants, develop repeatedly flowers. Um, Given that 16, 18, I think both works, but so there's another physiological issue strawberry has, and I didn't have a chance to talk about. It's a tip burn. Tip burn happens when nighttime is limited. And then particularly nighttime is the low humidity situation. It's a massive tip burn happening. So that it's actually good to have long nighttime. Like to me, 16 hours, 8 hours night, 16 hours photo period, 8 hours night. It's probably what I would start with than 18 and 6 because of that.
Yeah, perfect. That's very informative. The next one would be, could I compare the environmental effects of field versus CEA growing? Is one or the other more sustainable for the environment? How to measure that? It's a pretty broad question, but is that possible? Is there a way to measure the environmental impacts of growing strawberry in CEA versus open field? Yeah, CEA versus open field.
Environmental effects on,
Well, that's a broad question.
yeah.
They don't specify. Maybe carbon emission. I'm not sure.
Oh, so yeah, so any CEA production off season is a high input, high output type of production system. So you have to heat, you have to use energy. Um, so well, for example, if you're using a traditional energy source, and then you might say that carbon footprint is way higher. But for example, the vertical farm doing a totally electric lighting and then electric heating or cooling actually, and then the energy source is a renewable energy, then you can say that even though it is a high input type of situation, carbon footprint is renewable, right? Or the more sustainable.
Yeah,
So it's depending on the how you design the system.
sure, sure. Next one, Cherry, is for the night temperature, you recommend around 10 to 12 C. Would you recommend those temperatures also for day neutral cultivars?
Yes, definitely
Mhm.
yes. So the night temperature recommendation is for the fruit size and then also fruit flavor. So
Okay. Another one is, did you get a better pounds per meter square productivity under supplemental lighting? If so, what was the difference?
So strawberry's productivity is, yeah, so let's say, which way I should say. So, okay, so the over the canopy area, strawberry productivity is somewhere like 3.5 grams per every single mole you add per day. So if you are adding 5 moles per day, you can get 3.5 times 5. So you can get 17.5 more yield per day. And then you have so many days, right? So they multiply by that. And then you get some idea of how much yield increase you can achieve.
Sure. Yeah. Well, so then they need to calculate specific to their conditions, right? Days and photo period and everything. That makes sense.
Right.
Yeah.
But we can help, so that's what we do in 1-day strawberry training. We usually pull out the environment data, potential DRI in the greenhouse, potential months you can grow decent crop, and then find out what is the potential yield based on our baseline data.
Okay. There are several questions about spectrum. So I'm not going to read any of those because it's a mix of, but in general, they're asking if you was able to see, notice, or quantify some sort of spectrum impact on the flavor. You mentioned a lot about the flavor. You talk about the temperature, some other facts. Have you looked into the spectrum as well? How is that potentially affecting the crop quality?
So no, we haven't, because we didn't have a chance to work on the spectral effect over the. But one thing let me go back. So we know UV is intensifying color of strawberry. If you have a strawberry crop in a polycarbonate covered greenhouse, your color intensity is very, very low. So that's not recommended. That's the only thing I know. And then because we changed from a sort of acrylic, which is close to glass, to ETFE, which is a very, very high UV transmission, we improved the color of strawberry quite a bit. But other spectrum like red and blue, and I think some other researchers might be working right now, but I don't work on that area at this point. And then I don't have a conclusive information of the light spectral effect on strawberry flavor.
Perfect. And you already answered. Someone else asked as well about the potential impacts of light outside the PAR region. So you just mentioned about the
Yeah,
UV.
UV. Yeah.
Anything about the infrared? You would comment on that?
Far red, no.
Okay.
I think somebody probably is working on that. And then I don't work on far red on strawberry. But far red potentially, improving morphology. So potentially a good way to use the light quality.
Yeah, and you mentioned about you talk quite about you're going to investigate the fruit temperature.
Mm-hmm.
So maybe these longer wavelengths could play a role there as well.
Oh yeah, definitely. Yeah.
That could be something more related to the temperature, right, than the color of light itself. But,
That's right.
okay. There's another cluster of questions about light intensity. So you mentioned a little bit about different photo periods that you look, and some questions about light intensity.
Okay.
Any comments about that, Cherry? Our strawberries, is there anything you can trigger by exposing them to higher light intensities versus longer photo periods with lower light intensities. Any comments around that?
Yeah, so I said the range I want to achieve in terms of DLI is 15 to 25 moles per square meter per day. Beyond that, strawberry gets stressed. They don't like to highlight. So that's what we want to avoid. That's why we put a lot of shade in Arizona in the highlight season. Instantaneous light, strawberry can take quite highlight if it is early in the morning, but they kind of start declining photosynthesis toward the end of the day. That's another work my graduate student Carter did, quite interesting work. They are very sensitive in the sink and source, and they are slow to translocate sugar from the leaves to the fruit. So that's why sugar accumulate in the leaves and then slowing down the photosynthesis. And so if I have a lot of money, I want to work on that again. You know, how I can maintain the photosynthetic capacity throughout the day with lighting technology or something. But anyway, so that they are also sensitive to the light intensity. Yes.
Perfect. We're getting close to 10 minutes past 3. So I'm going to read one last question, and then I think we can finish here the session. One question was about going back to the systems. You have the movable systems that go up and down. Is that mechanical? Are those mechanical systems, mechanized systems? Is this commercially available?
So I think I haven't used because my strawberry house is 1,000 square foot. But I know it's just, you know, to push the button and then, or maybe, I don't know. It's because it's a on-demand type of, you know, moving up and down. So it doesn't have to be automated. But okay. it has to have a motor, I think, to bring that thing up and down.
I would imagine it as well. Yeah, if it's a commercial facility.
Yeah. There are a few companies, you know, producing and selling that. And then I copied one of the Canadian companies' site information.
Perfect. Well, Chieri, thank you so much for the presentation. Just before we go here, I want to make a comment. I mentioned about the eggnog. Someone comment that actually exists. They call eggberry nog, and it's available in Florida. Just want to make the comment here.
Oh, that's nice.
Yeah, someone is saying that it is available out there. Thank you so much for the presentation. We had most of the people join us all the way up to now, 10 minutes past the time, so that's a great sign. There's so many other unanswered questions. I apologize, we don't have time to do that. But I want to make sure to tell everyone that this webinar will be available, the recording, at the Glaze website. If you cannot find there, just send me a note. We upload them to YouTube within a week, so everything would be available. Chieri, any final comments? Anything else you'd like to tell to the audience?
Well, I would like to thank Glaze and then you, Eriko. It's a wonderful, wonderful opportunity. Thank you so much.
Thank you so much, Chieri. I appreciate that, your support, your willingness to share the information, and I look forward to the next one. Thank you so much, Chieri. Have a good day. Thanks everyone who attended over the phone and the computer, and I see you next month with our next Glaze webinar. Thank you. Bye-bye.
Great. Thank you.